Chapter 2, Question 8. A pair of speakers separated by 0.7 meter are driven by the same oscillator at a frequency of 686 Hz. An observer originally positioned at one of the speakers begins to walk along a line perpendicular to the line joining the speaker. So A. How far must the observer walk before reaching a relative maximum in intensity? The idea is that the person, which is observer, starts at one of the speaker and walks straight north from that speaker, so that there is a right triangle created between him, one speaker, and the other speaker. The hypotenuse of this triangle is the line from the person to the other speaker. Now the idea is that we will get a maximum when two wave grids coincide. Since the frequency is 686 and the speed of sound is 343, the wavelength will be 0.5 meter. For the person to stand at a point where two waves constructively interfere, the path lengths for the two speakers must be differ by exactly one wavelength, or an integral multiply of wavelengths. The first such maximum occurs when the two path lengths vary by 0.5 meter. This means that if the distance from the first speaker is x, the path length along the hypotenuse is x plus 0.5, and the Pythagorean theories tell us that the equation will be like this. So when we solve the equation, we will get the answer is 0.24 meter. Thus he should move 24 cm away. We will move to question 8b. How far will the observer be from the speaker when the first relative minimum is detected in the intensity? To find a minimum where the wave destructively interfere, the path lengths must differ by a half wavelength, which will use the destructive equation, which is 1 plus 1 over 2 multiply with lambda, which is we will get 0.25 meter. This means that if the distance from the first speaker is x, the hypotenuse is x plus 0.25, and the Pythagoras tells us like this. Then we'll get the x as 0.855 meter.